Hello everyone! A number of years ago, I created a tutorial for creating Squinched video for use in Planet Coaster. In that video, I demonstrated a method that uses Adobe After Effects and Video Copilot's Element 3D. At the end of the video, I mentioned that the basic concept could likely be implemented in free software, such as Blender. Well, I'm happy to say that I have found a very good method for achieving these results entirely within Blender, using no paid software at all. In this tutorial, I will demonstrate my new method and how to incorporate it into dark rides in Planet Coaster. I am not going to cover the math behind the concept, as it is unnecessary for achieving the effect. Before we dive in, let me give a brief explanation for what squinching is. Squinching is a process for distorting video to match the perspective of a moving ride vehicle, so as to give the impression that the riders are not looking at a screen, but rather at actual dimensional space behind, or in rare cases in front of, the screen. This technique dates from the late 90s, but has become much more popular in recent years, as theme parks have begun relying more heavily on projection and LED screen effects. While an over-reliance on video screen effects in dark rides is, in my opinion, detrimental to themed entertainment, there are certainly some extremely creative uses for this technique, and for a game like Planet Coaster, where our ability to import custom scenery is relatively limited, this is a very powerful tool. I am very excited to see how people use this technique. For the purposes of this tutorial, I will be using a section of a hypothetical dark ride. In this dark ride, riders are chasing a time-traveling outlaw, and for one scene, I would like riders to see the time traveler materialize out of thin air, then throw a magical fireball at them. Obviously, this is not something that can be achieved in vanilla Planet Coaster, even with the use of the theme maker's toolkit. Here is the section of track that I'll be using. Riders will round this corner, looking down this hallway. At the end of the hallway, to the right side of the track, will be our screen, where we'll be able to see into a rundown bathroom where our time traveler will appear. The first thing we need to do is establish at what point the screen will activate. Just like with the previous method covered in my old tutorial, certain decisions have to be made now, such as the layout of the track, the speed of the vehicle, and the location of the trigger to turn the screen on. Once we move into Blender, we are locked into the design in Planet Coaster. We can continue to add scenery, audio, and additional animation or lighting triggers, but the motion and timing of the vehicle cannot change. I have the trigger to activate the screen right here. As the vehicle rounds the bend, the screen will turn on. Right now it's just showing a generic image, but that's okay. We're going to be taking a screen recording of this, and we need to be able to see the moment that the screen activates. It will also be useful to see where the screen intersects with the height of the riders in the vehicle. I'm going to be using the center seat on the front row, so I can set up some flat art shapes at the same height as the test dummies in the first row, and have those just barely intersecting the screen. To get the best possible recording, we're going to use Planet Coaster's security cameras. I have one placed directly above the scene, high up in the air. We're using the security cameras because they have the ability to zoom in and out, and the farther away we put the camera, the less perspective distortion we'll have in our screen recording. I am going to be using OBS to record my computer screen, but you can use any recording system that you like, such as QuickTime on a Mac, Fraps, or even an HDMI capture card. And there we go. I'll just scrub through the screen recording and make sure that we can see the moment that the screen activates, as well as the movement of the ride vehicle as it moves along the track. For this tutorial, I'm going to be using Blender 4.1, which is the most recent release at the time of recording. Blender is an incredibly powerful program for 3D modeling and rendering, and while I'm going to be doing my best to explain as we go, I am assuming that you have a basic understanding of Blender's interface and how to use the software. If this is the first time you are opening Blender, I highly recommend checking out Blender Guru's Beginner Donut tutorials, which will get you familiar with the Blender interface and the basics of using the software. The first thing I'm going to do, after performing the traditional deleting of the default cube, is import the footage we just captured from Planet Coaster. I'll align my view to the top-down orthographic view, and then hit Shift-A to add an image, reference image. I'll select the screen recording that we made and add that. And I'll scale this up just a little bit to make it easier to work with. Next, to make sure it plays properly, I'm going to go into the Properties panel, and in the Data tab, I'll click on this little refresh button, which will set the number of playback frames to be equal to the length of the video file. Now I can scrub through the timeline and make sure that we're able to see the vehicle moving. You may have to zoom the timeline out a bit, but we're going to find the exact frame where the screen turns on. It looks like frame 243 is where the screen activates in my recording. So in this case, I'll set the start value to 243 and the end value to 873, which I know is the end of my recording. Next, we need to know where the screen is. I'm going to hit Shift-A and add an empty. Any type will work, I'll just use the plain axes. I'll position this one on the left corner of the screen, using our art shapes to determine the height of the ride vehicle's eyeline. I'm going to call this empty bottom left. Then I'll duplicate it with Shift-D, then hit X so we're only moving it on the X-axis. And I'll position this on the right edge of the screen. It is critical though that we only move this on the X-axis. It needs to have the same Y and Z values as the other empty. Now I'll rename this bottom right. So now we have the bottom left and bottom right corners of the screen picked out in Blender. Next, we need to find the top left and top right, and we're going to do a little math for this. We know that the aspect ratio of the screen in Planet Coaster is 16:9, but we don't know what scale we're working with in Blender. I'll click on the Measure tool in the left set of tool buttons in the 3D viewport, which you can hide and show with T on the keyboard. Next, I'll turn on snapping and set it to snap to vertices. Now I can measure the distance between these two empties very accurately, and they are 4.39051 meters apart here in Blender. Using the 16:9 aspect ratio, we can mathematically solve for where the top left and top right corners are. My math says that they should be at 2.4696, so I'll select both the left and right empties, duplicate them with Shift-D, then hit Z to restrict movement along the Z axis, and move them up by 2.4696 meters. Lastly, I'll rename these empties to top left and top right. Now we know the location of the four corners of the screen. Let's get our camera in here next. I'll hit Shift-A and add a camera. I'll come into the Add Camera options and make sure that the rotation is set to 90, 0, and 0. Right now the camera is at a height of 0, but in Planet Coaster, the camera is at the height of the dummies in the ride vehicle. The exact height will vary depending on the ride type and which seat you plan to use for the ride-through, but in this case I've measured it to be 1.9 meters above the ground. Now, since we know that 8 meters in Planet Coaster is 4.39051 meters in Blender, at least for this specific setup with my screen recording and how I've scaled it up in Blender, I can convert those 1.9 Planet Coaster meters to 1.04274 meters here in Blender, and set the camera's Z position to that. By the way, this is a good time to save. I'll give this a nice name and click Save. Now we are ready to capture the ride vehicle's movement. With the camera selected, I'll hover my mouse over the location values in the Properties panel and hit I to turn on keyframing. Down here in the timeline, I'm also going to turn on auto keying, so Blender will automatically add keyframes for me. I'm going to go into the orthographic top-down view, position the camera over the head of the middle dummy in the front row of the ride vehicle, which I know is which seat I'll be using for the ride camera. And now I'm going to just go through and move the camera to follow that front middle dummy as the ride vehicle moves through the track. Note that I'm not touching the rotation at all, just the position of the camera. And at this point, the ride vehicle has turned away from the screen, so I'll finish here. And actually, I'll set the end value for the timeline to this, so we don't end up rendering out more than we need to. Now comes the fun part, putting the scenery in. I am not going to cover this extensively, since I am by no means a professional modeler, shader, or animator. In fact, I'm going to be using only free assets that I've downloaded online, particularly this kind of dilapidated old bathroom scene by Evan on Sketchfab, as well as the Abe character and a couple of animations from Mixamo. Lighting and animating this part may take a while, so I'm going to jump ahead to where we get back to the actual squinching process. Okay, so here's what I have. Our time-traveling character appears, looks around, spots the guests on the ride, and throws a magic sphere at them. Now let's actually perform the squinching process. These next few steps are a little complicated if you are new to Blender, but they are what makes the magic work. I'm going to switch into the scripting workspace of Blender, and I'll click New to create a new script. I'm going to call this squinch.py. Now I'm going to go to GitHub and grab my Python script. The link for the GitHub page is in the video description down below. I'll copy and paste this into the Blender scripting window. At the top, you'll see that there are 4 variables that are currently just placeholder. We need to replace these with our empties for the top left, top right, bottom left, and bottom right. I'll highlight the first placeholder, then in my scene outliner, I'll click and drag my bottom left empty into the scripting window. I'll go ahead and repeat that with the bottom right. Top left, and top right empties. To register these new script functions with Blender, I'm going to click on the button up here that looks like a play button. This will allow us to reference horizontal FOV, get horizontal shift, and get vertical shift from drivers in Blender. Drivers are a lot like expressions in After Effects. They let you use little pieces of code to generate values for whichever field they're associated with. We have 3 functions in our Python script that we can use as drivers for our camera. Using values we pass to the functions, they will calculate the exact numerical values we need to make the squinching process work. With the camera selected, I'm going to go into the Properties panel, and in the Data tab, the 3 values that are relevant to us here are focal length, and Shift X and Y. I'll hover my mouse over the value for focal length and right-click on the value, then select Add Driver. This is the Add Driver panel, but it disappears if we move the mouse away. So we'll use a different method for editing the drivers. But first, let's repeat this process for the Shift X and Shift Y values. We know that everything is correct if these three values have turned purple. Now let's actually set up the drivers. In the scripting panel, I will select this button to change which panel is displayed here, and we're going to use the drivers panel. We still have the camera selected, so we can see the three values that are using drivers right now. Let's start with focal length selected. I'll hit N to bring up the right side tabs if they're not visible, and select the drivers tab. In the expression field, I'm going to type horizontal _ FOV, followed by an open parentheses. Next, we can pass the driver certain variables. For the horizontal field of view, we're going to type Y, Z, sensor _ width, and then a close parentheses, and then I'll hit return. This isn't working yet because we need to tell Blender where the values for Y, Z, and sensor width are coming from. We can do that using input variables. Blender gives us this default one, var, but we can hit the X and delete it. To get our input variables, we're actually going to go into the Properties panel under the Object tab, and we need Location Y. I'll right-click on the value here and select Copy as New Driver. Back in the Drivers panel, I'll click on this button with a clipboard and a down arrow. This will paste the Location Y value as an input variable. And let's rename it from Location to Y. I'll repeat that with Location Z as well. Copy as a new driver, paste, and rename to Z. And lastly, we need sensor width. That is in the Data tab right here. And again, right-click, copy as new driver, and paste. This one already has the correct name. And now we should see the error message saying invalid Python expression disappear. Now let's get Shift X linked up. I'll select Shift X in the driver window, and in the driver property tab, the expression for this one is get _ horizontal _ shift. And in the parentheses, I'll put X. Just like before, I'll delete the default var input variable, and in the Object tab of the Properties panel, I'll right-click on Location X, copy as new driver, and click the Paste button in the Drivers panel. And I'll rename this to X. And last one, Shift Y, and the expression for this one is get _ vertical _ shift. And the variable name for this is Z. Delete the default input variable, copy the Location Z field as a new driver, paste it in, and rename it to Z. And that should be it. I'll switch back to my layout workspace, jump into the camera perspective, and that all looks correct. I'll scrub through the timeline and we can see our camera squinching correctly. So I'm now ready to render. I'll go into my Output Settings tab in the Properties panel, set an output location, and under File Format, I'll select FFmpeg Video, and set the encoding container to QuickTime, since I've had issues with the built-in WebM encoder. If you are familiar with Blender, this is the point where you can set your render engine, adjust any render parameters like bloom or ambient occlusion, etc. Everything looks good to me, so I'll select Render, Render Animation. So here we are in Planet Coaster. Off screen, I've converted the rendered footage to a WebM format and put it in my user media folder. All I have to do now is set this as the media for the screen and hop into the ride camera. That looks pretty good to me. As we wrap up, there are a couple of things to note about this technique. As I mentioned before, the camera and the markers for the screen must be aligned with the x-axis, and the screen must be perfectly vertical, it cannot be tilted. In theory, the Python script can be adapted for off-axis screens, but that requires some more advanced math than I'm capable of. This technique works with both the Eevee and Cycles render engine, and you can put absolutely whatever you want into the scene. I highly recommend checking out sites like BlendSwap, Sketchfab, BlenderKit, Mixamo, and Polyhaven for high-quality Creative Commons models and materials. When you quit and reopen Blender, you may need to click the little play button in the script editor panel to re-register your script. Then click in the driven value fields and click out to have them update. I am extremely excited to see what people do with this technique and how it is implemented into people's parks and rides. Thank you for watching.